Vijay sir, are you there?
Hi, good afternoon.
Yes, good afternoon. Thank you. So I request our Professor Nagesi Kamal sir to welcome our expert resource person to this virtual virtual presentation. Word to Nagesi Kamal sir.
Thank you, Naveen sir. Good afternoon to all the participants and our expert, Mr. Vijay Varada. It gives me immense pleasure to introduce our expert for this afternoon session on day 2, session 3. It is based on disruptive applications of 3D printing in Indian industry. Mr. Vijay Varada is an entrepreneur who is basically a mechatronics engineer with a working knowledge of product design and has enabled him together to bring in many advancements in the disciplines of engineering to build mechatronic systems, robots, and industrial machines. He is the CEO and director of Fracktal Works, a 3D printing hardware and solutions company, Bangalore, which he started at the age of 20. He is engaged with design and research and development areas in additive manufacturing and is actively contributing to open source hardware projects, particularly assistive technologies for the renewable energy sector. His projects have won many accolades, including the best product and also third place at the AICTE Prize 2018 USA, among many others. He has built an open space 3D printable wind turbine and has demonstrated its capabilities in an expedition to Antarctica with the great polar explorer Robert Swan. He is also an author, a TEDx speaker. He has written many technical books for children and has published in multiple international languages. Being so young, we are all very excited. Of course, young means we are all eager to know from the experiences that you have at such a young age as a co-founder of a company. And we would like to now hand over to you. Please take over the session, Mr. Vijay Varada. We are all eager to listen to you.
Thank you so much, sir, for that introduction. Before I start, just check, am I audible to everybody?
Yes, sir.
Yes, sir. You are audible.
Yeah, if it helps, you can probably turn on the captions on the lower right of your screen. You have that option, turn on captions, right? It always helps. It gives you a better sense of learning when it comes down to forums like this. So thank you so much for that introduction. I'm really excited to share what I have. I think I come from another part of 3D printing when it comes down to, where the rubber meets the road. How are we applying 3D printing in the Indian industry? And so a lot of the things that I'll be sharing today, I will not be talking about the process. I'll not be talking about 3D printing. I think there's enough talks about that. And since you're on this forum, I think most of you are already familiar with most of the technology around 3D printing. So my talk is going to be concentrating on how you can use 3D printing to apply it to disruptive applications and how it can possibly take the Indian economy forward. And I'm going to speaking about like four to five main applications of 3D printing and how it applies to Indian industry. And I realize, again, this is for the first session after lunch, so I'll try to make it as exciting as possible. I'll keep the talking part as less, probably half an hour, 45 minutes. And we can probably have a much more open discussion after that, talking about how you could use 3D printing and what, again, from your experiences, your domain expertise, what are the questions that you are having from, how 3D printing can probably apply to your domain expertise. So let's start. And I think before we start, I think it's a good idea to, give you an understanding of who we are as a company, what are we doing in 3D printing in India, what do we really do? and what have you really used 3D printing? What does the art journey with 3D printing look like? So what are the things that we've done with 3D printing? In 2018, we set up the world's first 3D printed wind turbine in Antarctica in the nation's colors. And this is sort of demonstrating the usage of 3D printing again, and making the access to high quality manufacturing ubiquitous, right? And I think us as a company, we really, even though we're technologists and we go hardcore into building better machines every day, we love using this technology and trying to apply it to solve different problems. Another project was using 3D printing to build an open source braille keypad that the blind can use to use can use to use a smartphone, because smartphone doesn't have any physical buttons. During the pandemic, we used 3D printing for again, while global supply chains were broken down, nobody was manufacturing anything. We were able to get started with manufacturing and use our 3D printers to distribute over 2 lakh face shields and PPE kits to healthcare workers and frontline workers all across the country. So the last year has been really exciting for, you know, how 3D printing has enabled us and sort of come back into the limelight about how this different route to manufacturing can be beneficial to all of humankind. So basically, 3D printing has enabled, say, for example, a couple of college students. I mean, this was the robot that we were building in college, and you know, there's just plywood and bits of plastic and things like that, and 3D printing sort of enabled us to start our own company when we were still in college. And I think this is sort of the significant aspect, and one of the reasons why I love 3D printing is sort of it levels the playing field when it comes down to high quality manufacturing. It democratizes manufacturing. It gives high quality manufacturing within the hands of everybody. And I mean, our 3D printers would manufacture parts for other 3D printers, and we would meet up after class and build machines. And that's how we started up the company when I was in the 3rd year of engineering in MIT Manipal. And it's been 8 years since then. And since then we've grown the team. We're building large industrial machines in FDM, and now we're getting into SLA as well as the MIM space when it comes down to metal 3D printing. And so 3D printing itself has enabled us to build better product and move up the value chain when it comes down to technology. So coming to the big why, right? Why are we doing what we're doing? Why am I here in this talk talking to you about the applications of 3D printing? Is because over the years, I've seen how exciting 3D printing can be, how liberating 3D printing can be, how empowering 3D printing can be. But all of these stages are just examples, really, because the majority of the industry is still using traditional processes while 3D printing exists. And my hope is to use this forum as you know, to plant the seed of curiosity about how 3D printing can apply to actual industry and actually add value to those industries, and thereby adding value to the Indian economy. And I think 3D printing has a big role to play in the Indian economy, and we'll see also why I think so in the following slides. So without further ado, let's get into the disruptive applications of 3D printing in the Indian industry. But before I do, I mean, I did mention that most of you probably already are familiar with 3D printing technologies. So I just want to underline the differences between 3D printing and traditional manufacturing, not in the form of technology, like this is additive, this is subtractive, all of that, but what does it mean in terms of economics? And I think that will give you context to the applications that I'm going to be talking about. Like, what does the core functionality of 3D printing have to do with the economics of manufacturing, and why exactly is 3D printing seen to be this next revolution? It's not the fact that it's additive, but the fact that it means certain things to the way in which we manufacture products today. So one of the things is that 3D printing is a form of direct digital manufacturing, DDM, direct digital manufacturing, where you take your CAD file, your 3D design file, and you send it to a 3D printer, and it gets manufactured in one single step, and you get a final product. This is in contrast to how traditional manufacturing works. Say, for example, CNC machining, or again casting. You have several steps in between where you are manufacturing the tool, using the tool to manufacture the final product. Say in injection molding, making the tool first. In investment casting, you are making another tool. You making the wax master, coating it with slurry, burning it, pouring metal into it. So there are multiple stages in that manufacturing process. Whereas in 3D printing, the one-step manufacturing process. And I think this is important to understand when it comes down to comparing these traditional technologies with 3D printing. Another question that I get very commonly asked is, is 3D printing going to replace traditional technologies like, say, CNC machining or injection molding, or is 3D printing just too slow to compare? So the answer to that is yes and no. Again, 3D printing will replace traditional manufacturing in certain applications, and in certain fab applications, traditional manufacturing is still going to be the way to go. So 3D printing and traditional manufacturing are going to work together. Why is that? Say, for example, if you can look at this graph. So this line over here shows the graph for how the cost per part changes as the quantity of parts being produced changes. When it comes down to 3D printing, the cost is more or less linear. Whether you're printing one part or 1,000 parts, again, various 3D printing technologies, the cost per part more or less remains the same. Say in a formative, in subtractive machining or in injection molding, the cost of making one part is incredibly expensive, because say you have to create the tool path, you have to figure out any tooling that you require. Say in the case of injection molding, there's a large cost when it comes down to the initial setup, your non-recurring expense, your tooling expense. And with every subsequent part that you make, the cost of 3D printing cost of that part comes down. So there's a clear sort of break-even point where additive manufacturing is preferred over subtractive manufacturing, and vice versa, right? So it really depends on the quantity of parts that you are manufacturing. So depending on the quantity of parts that you would want to make, you would select between a traditional manufacturing process or 3D printing. But there is a caveat to this, when it comes down to complexity. Because of the way in which 3D printing functions, because of the way in which it adds layer by layer, and how you have complete geometric freedom of design, there may be some applications where you just need 3D printing and cannot do it in any other way possible. So if you see over here, there's nothing else in this quadrant. 3D printing is the only technology where you can get high complexity. And there are a large number of examples of this, where again, because you're consolidating various parts together in one complex part, especially when the volumes required are low. For example, in performance automotive, in aerospace applications, where volumes are low but complexity is very high, there 3D printing becomes a perfect candidate for use for manufacturing compared to traditional technologies. And lastly, last slide before I get into applications of 3D printing is, what do I mean by disruption altogether? Right? What is disruption? 3D printing is called a disruptive manufacturing technology. What is disruption? So basically, disruption if your traditional uh, um, uh, quality of your traditional way of manufacturing, the way in which the quality, time improvement, etc., improve over time. uh, Say this is how traditional manufacturing would go, but disruptive technology takes a completely different route altogether, and it surpasses how traditional technology becomes better and better over time. So, say for example, injection molding might get slightly incrementally better over time when it comes down to cost, but say 3D printing can completely take a different trajectory when it comes down to replacing injection molding. So that's what I really mean by how 3D printing can be disruptive in several industries, is because they take a completely different graph altogether when it comes down to, say, how casting or forming or forging works. So with that, we start on the different applications of 3D printing, which I've seen startup in India, are directly working with, and are possibly things that would require people like yourselves to research more and apply them to so that more industries can adopt it. Starting with a medicine, and particularly pre-operative surgery planning. Pre-operative meaning this planning is done before the surgery. And let me explain this with an example of total hip arthroplasty. Basically is like your hip replacement, and how from a CT scan, starting with the CT scan, you can see that from the X-ray that on the right side of the pelvis, there is a pelvic defect with severe, I think it's called a acetabular defect, and basically again the porosity of the bone has increased, and you can see it in the CT scan. So what doctors do will take the 3D model of the scan and then 3D print it, and they can easily, with this process itself, with 3D printing, just to look at it in addition to CT scan, they can figure out all the parts of the bone which have the deficiency, and they can plan the surgery a lot better. Not only that, the model, for example, in hip replacement surgery, this is actually a drill that is used to drill a cavity in the leftover bone so that implant can be made. And instead of actually doing this on a live patient, all of these things are done on the 3D printed part in itself. So the model allowed the pre-operative surgical drill with simulating the position in which the drill should be placed. And afterwards, the acetabular cup are selected. Again, what is the size of the cup, the ball socket that needs to be implanted into the hip, and all of this was done on 3D printed part itself. Now, traditionally, you'll be surprised that traditionally all these steps are done on while the patient is on the operating table itself, and doing this beforehand, making sure you've selected the right components, you know how your tooling is going to work, you know how to where to sort of remove material, remove the bone and drill. It improves the chances of the surgery success. The patient is on the operation table for a much lesser amount of time. The doctor is not as stressed, and the chances of success in the surgery is way more. Another example where this is of an example where 3D printing was used as an implant itself by one of our customers. So it started with a 3D printed mold that was created using the negative of a bone flap. So there was a trauma patient met with the accident and lost a part of her skull flap, and so that part of skull flap was modeled on a computer. The negative of that was taken and the mold was created, and using bone cement and titanium mesh, a skull flap was created and was then subsequently implanted into the person. So you don't really need to again, so this is how this is an example of implants. So we've seen how 3D printing can be used for pre-operative surgery planning, where again it's completely non-invasive and it will help doctors perform the surgeries better. And I've also seen an example of how it helps in implants as well. So in summary, for this particular application, 3D printing helps an accurate get to an accurate diagnosis when it comes down to maxillofacial surgery, when it comes down to any sort of orthopedic surgery, and determines the best course of treatment in the pre-operative planning process, where the entire surgery can be planned out before actually being performed. Next, we'll look at transportation. Now, there's a lot of interesting things happening in this space. Say again, starting with, let me just give you an example of the kind of things that can be 3D printed from electrical connectors, hand rests, and headrests, the food trays, the industrial HVAC systems, the air conditioning systems. So all of these parts are generally, say, for example, if you take a train, for example, these are custom made for that one train. And again, these are, I mean, knowing about 3D printing, it's straightforward to know that, okay, fine, you can manufacture these parts on a 3D printer, but what are the benefits of it? So let's look at that. So I've divided all the applications of 3D printing, and I'll talk to you about the kind of parts that you can do with 3D printing across these 4 categories. Starting at bridge parts. Now, what are bridge parts? So basically, in rail, in any, whether it's metro rail or it is intercity rail, interstate rail. So the cost of having a coach or a train out of service is massive. So the cost of having a single commuter train out of operation is lakhs of rupees in a day. And with the financial penalties adding up quickly, finding replacement parts in-house is in a fast manner is critical, because the alternative to this would be that the train would be needing to be kept out of commission for weeks. So bridge parts are basically parts which are used while you are still figuring out where you're getting the end parts done. So it becomes a bridge between your problem right now and a solution later on. Next comes low volume spare parts. So again, taking the example of rail, costs for spare parts in the rail industry are incredibly expensive. This is because generally the service industry, the second tier vendors, third tier vendors have to hold inventory for 30 years plus. And again, not only keeping stock for 30 years is expensive in terms of carrying costs, shrinkage, spoilage, but it is inevitable that that some parts will go out of stock. And when some parts are just not available in stock, they have to be recreated from scratch. So this is where, again, 3D printing is a massive game changer when it comes down to, say, rail industry. Quality process improvement. Well, say with world-class manufacturers, they always employ several tools to mistake-proof their operations and ensuring a high pass yield. So everything that they do, so that again they reduce human error as much as possible. This can be something as simple as a drill guide or a fitment checking device or a key guide so that something is installed correctly. But again, this basically keeps the inventory losses at a minimum. It ensures quality and things like that. Finally, coming down to customer experience, say it comes down to say you buy a railway coach or a car or any sort of transportation device where it has to be customized to a particular requirement, or it has to be customized to a particular city or use case or a particular kind of demographic. So you can improve customer experience a lot by custom making a lot of the parts with 3D printing. And again, I've talked to you about the kind of parts that you can make, explained, what are the different categories of parts. But I think the next slide will give you a good understanding about, the disruption that will take that 3D printing brings. So say for example, if you're starting production of one part from day one, starting with your supply chain costs for say your raw material and things like that. So again, comparing 3D printing in these initial steps itself, the cost of 3D printing again has very low barrier to entry. You're not spending a lot of time, or again, this is not this access is not time but number of parts. So again, if this was also when it comes down to time taken for these steps will be a lot more rapid than these steps. So sourcing the parts, designing and creating the tooling, the cost incurred for the setting up the production itself, all of these costs a massive amount when it comes down to traditional manufacturing. And thinking back to the earlier graph that I showed you about the break-even point, right? So if your reorder volume for your spare parts, or the volume of parts that you require is less than a certain amount, you just can't justify the cost of using traditional manufacturing. And the thing is, generally you have to overproduce and keep parts in stock, and then you have your inventory carrying costs, shrinkage, also again obsolescence, right? So you 2-3 years, 10 years down the line, will you still use that part, or will it change? So in summary, when it comes down to transportation sector, again, there's some interesting things happening with just-in-time spare part production with zero inventory and zero carrying costs. Basically, digital inventory is where your spare parts are created on demand when they are required, probably close to where the demand arises. Say again, if the warehouse is in Ludhiana and you need a part in Bangalore, again there's a lot of supply chain costs that requires, again, and it's produced somewhere else, possibly even outside the country. So there's the large part of the cost of that final part that is attributed because of the logistics involved. And again, I'm not even talking about the environmental impact over here that 3D printing can have, where basically you're doing high quality local manufacturing of your branded parts, and this is something that's really exciting. Quick adaptability, where if there's a defect in one part and somebody realizes that, you can quickly come out with iterations and deploy them. Right now, you don't have to wait for setting up the tooling. You don't have setting up production. You just have to create the digital part, and then you can start deploying it within your supply chain. So this is how, sort of, again, this is an example when it comes on transportation, but this example probably can be applied to any industry, any production industry with plastics, with consumer goods, with automobile, bikes, transportation in general. So zero inventory, quick turnaround, spare parts. So this is really interesting when it comes down to application of 3D printing in the Indian industry. Now coming to, I think, my favorite applications of 3D printing. So 3D printing for tooling. This is not, this is definitely the lowest hanging fruit, in my opinion, when it comes down to deriving value out of 3D printing, especially in the Indian industry. And we've done a lot of work with Indian customers across industries about how 3D printing can be used to lower the cost of tooling itself. So if I go back to this slide, right, the cost of tooling and setup is more. 3D printing, instead of you're still producing your parts in a traditional manner, but 3D printing is used to reduce these costs of tooling, cost involved in tooling. Starting with, say, casting. Now I'll be talking about sand casting as well as investment casting. So again, metal manufacturing technology, made for, again, volume manufacturing of metal parts. And casting in general, again, forms a large part of the Indian industry. I think India is second or third when it comes down to casting productions in terms of tonnage in the world. across automotive, power, railways, pipes and fittings, construction, sanitary ware, engines. Again, a lot of applications that use casting. So at least when it comes down to pattern making, right? So how casting works is that you need to make one of these patterns, whether it's an aluminum or wood, and this pattern creates a cavity in sand, and then you pour. The thing with these patterns are incredibly expensive. So the lead time to create one pattern is 4 to 6 weeks. Cost is pretty high. Again, we estimate of 1 to 3 lakhs for a 400 pattern. And modifications, again, if there's a critical modification, then the whole process has to start again. And again, even the process of creating these patterns are a highly skilled process for making it. So 3D printing really completely changes the game when it comes down to pattern making. You can see over here where we've put 3D printed patterns on a traditional what's called match plate, and use the same process which is used by aluminum for packing the sand in a high pressure um, sand packing machine. And then okay, even the cores, the core boxes that are used to create the cores as well. It's more or less at least in this case, the entire process of using CNC machining and wood patterns for making out of wood or aluminum is completely replaced by 3D printing. What are the key benefits of using 3D printing for say casting or sand casting in general? So average lead time savings is 30 to 70%, where again you can 30 to 70% are mods to 4 to 7 days, instead of waiting a month or two. Cost reduction is great, 60 to 80%. And because using 3D printing, you can always iterate things, right? For example, again, the casting industry is seen more of an art than a science when it comes down to how metal flows in the gating and runner system. So the process itself requires a few number of iterations. So for example, modifications when it comes down to the gating and runner systems of sand casting, and the optional use of interchangeable components if you need. So if something not working out, interchange it with something else. And so that's a really exciting thing to see when it comes down to 3D printing, where you are iterating the tool itself so that you are getting um, the parameter that you want. And again, 3D printing as a process for production as well is completely automated, right? Once you give the part, the process of manufacturing is automated. So how does 3D printing compete when it comes down to performance? So we did some research when it comes down to this. So wooden patterns is what is popularly used. Again, you would either hand carve it or use CNC machine wooden patterns, and it takes 2 to 3 weeks to make it. It costs 25,000. So this is what generally is done by the industry when it comes on low cost, low volume patterns. And because the sand has some amount of moisture, the wood absorbs that moisture, it bloats up, changes the diameter tolerances and things like that. So um, it's applicable less than 100 sort of sand molds. Aluminum pattern is what is used for manufacturing, high volume manufacturing. Again, your most automotive components only might be using aluminum patterns, and you can get really high volume with this. But again, getting this tool made is extremely expensive as well. But if you look at a 3D printed pattern, and this is a test that we ourselves had done, the cost of a 3D printed pattern is less than that of a wooden pattern, but is close to what you can achieve with a aluminum pattern. So you can think about even producing multiple 3D printed patterns instead of one aluminum pattern and running it in parallel. Or again, you might not even need these kind of quantities, and you actually need some quantity that is between wooden pattern and aluminum pattern, right? Why would you want to invest in an aluminum pattern at that point in time? So 3D printed pattern becomes sort of like a game changer for the casting industry, giving 5 times faster speed and 7 times cheaper when it comes down to, say, a metal pattern. Next kind of investment, next kind of casting is investment casting. How do you use 3D printing for investment casting? So how 3D investment casting differs is that, again, you would use a 3D printed master like this. This is made in a special material that burns out when you expose it to high heat. So this is coated with ceramic slurry and silica sand, and then it's burnt out, and all the plastic melts out and comes out, leaving a hollow cavity in the shape of that part that you want to make. And then um, you would pour molten metal and create your part. And one of the biggest bottlenecks in this process is that again, just like in injection molding, you have to create a mold for this particular pattern that you're making. It's just like an injection mold, but instead of like plastic, you're injecting wax. And the same cost of tooling, if you are prototyping something in metal and everything, it becomes really expensive. So 3D printing becomes really for using it for low volume manufacturing. And again, time also again takes 1 to 2 months for creating a die and then start production. With that, you can start making a part immediately. And again, you get high detail and resolution when it comes on 3D printed parts for proto samples. Not only that, another interesting thing is 3D printing the molds itself. We'll be looking at that later on. But instead of using aluminum to create the mold in which wax is injected, you can use a 3D printed mold itself, say possibly from SLA technology, so you get good surface finish and create the mold and then create these parts in bulk. So you can use 3D printing as a mass manufacturing process in investment casting. So I like this image. So all of these are 3D printed uh, core boxes, basically, in the sand molding industry, sand casting industry. So this is a customer of ours in Chennai, in Mysore. So he's completely shifted his process from aluminum to 3D printing because it just 3D printing gives so much more value versus aluminum and wooden patterns. So it's a little low barrier to start. You start using 3D printing. Coming down to, again, now I'm going to go rapid fire when it comes down to showing you a lot of different processes. So I dove deep into casting and investment casting and other applications. So I'll just show you on a sort of bird's eye view level what all when it comes down you can do when it comes down to 3D printing tooling, because this application itself is really vast and is game changing in several of the industries where it can be applied. So um, again, I'll go through these. Maybe we can have discussions about these things afterward if you want to know something in detail. So generally, I'm going to be talking about how 3D printing is used as a tool to create a final product, and a final product is not necessarily 3D printed in itself. Starting with injection molding, and both injection molding and blow molding for creating plastic bottles, either created in a blow mold. Both can be created using injection molding tooling. So you have a cavity in which you would put you insert your traditional insert your 3D printed mold, so that it takes care of a lot of the internal stresses and pressures that are built up. And again, a lot of these resins that are used for photopolymers in SLA process and DLP process can go up to 400, 500, 600 degrees working temperatures. So it can be used for low volume manufacturing of parts without the need for investing in an expensive tool. So before, you would have done your proto iterations and samples and everything with 3D printing itself, but you want to go for low volume manufacturing, say 500,000 parts. 3D printing becomes really expensive for making 500,000 parts in itself. So again, you can use 3D printing as a means to start producing as well. And there's another thing where basically while developing the injection mold, there is again that developing injection mold is also an iterative process where you are trying to figure out different features, what are the tolerances that you need to give, the shrinkage allowances that you need to give, a lot of issues that come up in the injection molding process itself. And if you're not sort of experienced enough or not working with an experienced vendor, this can be really a long, tedious process to get it right, and really expensive as well. So with 3D printing, sort of again, you're prototyping the tool itself. You are prototyping and improving it over the course of time. And again, you can get up to 50 to 1,000 cycles depending on various factors like temperature that's being used, the pressures that are being used. So 50 to 1,000 cycles of parts that you can make, and 50 to 100 times the reduction in terms of mold costs versus like traditional injection molding. And you can reduce lead times from 3 months to 1 week, so you can get started with injection molding really fast. So this is a really exciting application for how 3D printing can be game changing when it comes down to uh, injection molding. Second is sheet metal forming, and I think this is an interesting application just for the fact that 3D printing is really strong, and these are parts that are created in FDM that can be used for sheet metal forming, and both the brake tools are created and are joined in an industrial brake press, and I have a video that I'll show you that can illustrate how it's working. So this is bending 1.2 mm MS, and this is actually parts of our own 3D printer. So any custom angles that you need to give, or you needed to create a custom tool for forming sheet metal parts. Again, generally these tools are made out of tool steel. But if you're just doing a prototype run, you can use 3D printing to get your parts right before investing in an actual tool. Another thing is again your CMM jigs and fixtures. When you have a complicated geometry that you need to create for a CMM jig, it's important. So this is something that I've seen that most your machining companies that take up machining jobs, they will only do a sample inspection when it comes down to when they're doing all the jobs. And this is because of the high time required to set up a part on a CMM machine. But if you have a jig like this, where again you can just pick up a part, place it, and then you can automatically test different critical parts of your product. Again, you're giving much better quality assurance to your customers, which you're giving your machine parts. Another really exciting application is composite tooling. How you can use 3D printing to drastically lower the cost of composite tools. So either the composite tool can be 3D printed in itself, or can be used to cast a tool in resin. And once that tool is cast from 3D printed master, you can use it to create thousands of composite layup, both carbon fiber as well as glass fiber. So again, drone industries, whether it is your prosthetics, your aerospace industry can benefit greatly from 3D printing a composite tooling. And we had a Formula SAA team who was using this basically with 3D printed masters, uh, 3D printing a lot of the components, the steering wheel, things like that, by laying it up on a 3D printed tool. Next is welding jigs. So when you have a complicated weld to be welded in different angles, you can use 3D printing to hold it in different angles, and you have materials that will be able to withstand the temperatures required by this sort of application. Then we have again robotic end effectors in for pick and place robots, factory automation. Another important thing to consider is again these are all say composite 3D printed in carbon fiber along with nylon or just nylon. These are non-marring tools. Non-marring means they don't scratch or mar the part that is being produced. So that's one big advantage of using plastics in this industry. So because they're not marring. So if you're handling glass, or if you're say using tools for alignment on a car, you don't want to scratch the paint job by using something that's metal. So using plastic parts over there really helps. And again, the last thing that I'm going to be talking about today when it comes on to these applications is soft jaws. And I think this is something that is really exciting to me personally. So when you have complicated parts like this, especially if you're not using a 5-axis CNC, how do you hold this on a vise, right? There's no straight edge to hold it. So 3D printing can be used to create these custom tools for CNC, where again you're not only reducing time for placement. Again, your centering, everything is already done. So you can use these tools for augmenting traditional subtractive machining of aluminum parts with 3D printing to get more out of that, right? You can reduce the cost of CNC machining complicated parts by using 3D printing. So that with that I conclude sort of my main talk, and I think I have about half an hour, 45 minutes left, where I really want to open the floor up to you and talk about some of the things that I've mentioned. Maybe there's possibly the things that, I mean, we've done a lot of things apart from this as well, which possibly can be applied to things that you're working on. So if there's something going on in your mind that you want to talk about, discuss, let's do that right now. So I am opening up the floor for questions. And yeah, we can take it from there.
Yes, Vijay sir.
So Naveen sir, you can probably help me take questions on the
Yeah,
chat,
yeah.
and probably you can read them out to me.
Okay. We are waiting for their questions on the chat. Give them some time, they will ask. But basically, my question before let me ask before they ask. So, on a entrepreneur level or on a industry, small scale industries or MSME levels. So, if students or faculties intern or want internships also, something like that. If how your journey was there for going into starting this Fractal, that I wanted. I'm curious about going to that. So you
Uh,
have given a good idea about what is 3D printing, which are the areas. Apart from that, I wanted to ask that also. So let them ask the question. By the time you can answer.
sure, sir. I mean, yeah, that is a long story. But I'll sort of, I mean, neither me or my co-founder comes from a business background, so this is all new to us. So we taught ourselves finance, sales, marketing, operations, all after we graduated college. Because we were hardcore technologists. We were part of the robotics team in college, and I think I showed you a video earlier, right? So we were basically building robots while we were in college again for project work and competitions and things like that. And we wanted to get better at building robots. That's when we learned about 3D printing. And we built ourselves up as 3D printer as a means to help ourselves make our first robot. There's limitations when it comes down to the 3D printing process. So since we had time on our hands, we kept improving it over time. And then students and faculty from all over our college were coming to us to get their parts 3D printed, and that really gave us a lot of confidence about like the 3D printing process in itself, what it can possibly mean for so many other people, not just us. And our college had a business incubator basically, And then because we had that platform, we had the opportunity, we had a product, and we were like, okay, fine, let's see where this goes. And honestly, we were in the I was in third year of college. My co-founder was in second year of college. We didn't really have too much to lose. We didn't have to sit for placements or anything. As long as we were able to balance our academics, we thought that this would be a good opportunity to learn something new, business basically. And if nothing else, it'll look good in our CVs, and we'll get placed in a good company, or get to study MS somewhere nice. So that was honestly the mindset when it comes on going into entrepreneurship. And 3D printing in itself helped us a lot when it comes down to product development, building better products. You have an idea one day, the next day you have it in front of you, and you are already iterating it. I think that is, even though I wouldn't say that I'm a great engineer, or we employ great engineers, but I think the uh, the prospect of using 3D printing to help you iterate, become, take step by step, being better every day. I think that's a great advantage of 3D printing. And it's also very, it's a it's a it's a process, it's a technology that democratizes high quality manufacturing, and that is what is exciting to me. And that's the reason why me and my team are working to bring access to 3D printing to as many people as possible.
Lovely. That's a wonderful job you are doing. Any audience? Question in the chat box. Shall I read for
Yes,
you?
sir. Go ahead.
Okay. The question is from Popar, Mr. Popar. May I know what will be the largest dimensions of the parts you can create with? Means we may be talking about
Sure. So,
your machine
the
level.
largest machine that we have is 600 mm by 600 mm by 600 mm. That being said, you can always join parts together. We made really, really large parts. Let me see. So we've made one of. That being said, you can always join parts together. We've made really, really large parts. Um, Let me see. So we've made, one of our customers at least has made parts which is size of a 60 feet tall columns and things like that. I'll just stop sharing my screen. I'll probably share you. Um, I'll share you information about that. Basically, one of our architectural clients, he has 25 of our large format 3D printers, and I think that is the image that is there at the start of the presentation. So this is basically his setup, and he prints his large parts on the machine, then joins them together. And so 25 machines printing parallelly. So within 2 days, he can have like 10 feet, 20 feet, 30 feet column. And he's an architect, so he's been doing interesting things with using 3D printing for glass fiber layup, for making like large statues and large parts. So at one go, the largest part that we can make is 600, 600, 600 mm. But again, there are ways of joining them together and make one large part as well.
Yes. Any more questions? You can raise your hand and ask the question also. Unmute yourself.
I mean, if you're feeling shy, you can contact me on my
No.
email ID here, or again, this is my Twitter, Instagram, Facebook handle, whatever. So feel free to reach out to me and ask me questions offline if you don't want to ask me over here. I'd be happy to help you out.
So just on another side, how many machines do you prepare, and what is your business plan next onwards, or what are the types of people who approach you for machines directly you build, or you are customizing them and giving it on based on the requirement? What are your future plans also? That also.
Sure. So we're a 3D printing solutions company, and we build sort of, again, machine manufacturing is at our core. So understanding the process, understanding the technology, how the technology can be bettered, what materials can be used. So we have core when it comes to R&D about hardware and materials. But on top of that, we do a lot of application research about how 3D printing can be used in different domains, different sectors, and things like that. And that's like a large part of what we do as a company. Uh, we try to figure out, how 3D printing can really be used as game changing applications. And if you see our website as well, again, I will post the link on the chat. Hold on. You get a good understanding of what we do when it um, comes down to 3D printing. And what I'll also do is link a video. Hold on. So I've copied a few links and pasted it on
Okay.
YouTube on the chat, so you can have a look at the video, get a good understanding of what we do as a company, get an understanding about how we work with customers. So we have a very solutions mindset. Even though we are product manufacturers, we have solution mindset to how we work with customers. Because 3D printing is such a new technology, it's got so many materials, so many subclasses of technology. It's sort of overwhelming for somebody who has a problem to figure out what is the right technology for them. So we make machines. We've been making FDM FFF machines for the last 6-7 years. We are started to make DLP SLA machines right now. And through our network of vendors, we do metal 3D printing and vacuum casting and all sorts of derivative technologies of injection molding, even of 3D printing, up till injection molding and CNC machining as well. So customer comes to us with a problem, and we try to see how we can apply 3D printing to that problem, figure out the economics that is needed, volumes that are needed. How does it make not only a technical sense to solve that problem technically, but also economic sense to that customer. So as experts who understand 3D printing in and out, we justify the ROI of 3D printing to the customer itself. So whether that solution is installing machines or giving that customer service or giving a one-time service, we sort of figure out along with the customer how to interact with that. And when it comes down to what we're doing next, again, DLP SLA itself has huge amount of applications. A lot of things that I talked about today, from injection molding, tooling, to again a lot of applications, dental and jewelry, that open up with SLA and DLP, and will be probably one of the first indigenous manufacturers of SLA DLP machines in India. And we hope to again bring that out a lot, because jewelry is a big industry in India, dental is a big industry in India. I didn't talk about these industries because again the very straightforward applications for 3D printing is very well known. I want more touch about the applications that are not known as much. But yeah, we're really excited to apply these technologies to these domains, and probably that's what will give us that is the road ahead. We are also working on metal 3D printing with the MIM process, which uses MIM pellets, melts them similar to an FFF process, and then sintered to create parts in either metal or ceramic. So that's another thing on the roadmap for this year, and possibly sometime next year we'll be commercializing all these technologies.
Audience, do you have any questions to ask?
Sir, this is Nagesh Kamath from Mechanical Department. Uh, am I audible, sir?
Yes, sir. Tell me, sir. You're audible.
Yeah, yeah. While we just reading your introducing you to the audience, we came upon the mention of expedition in Antarctica, and
Yeah.
just as a curiosity, I'm asking how can you just elaborate on that? We are a bit interested in that. How was your 3D? What are the demonstration that
Sure.
you exhibited in? Can you just give us some more from the application point of view? Just from the
Sure,
application
sure.
point.
So basically, my aim going to Antarctica was promoting 3D printing and what it can mean for renewable energy. Now I built
Yes.
a 50-watt wind turbine. Now I wanted to go to Antarctica to build a story around that wind turbine, basically create like a viral story around, the first 3D printed wind turbine in Antarctica, and inspire students primarily to take up research in renewable energy. And the fact that 3D printing is an accessible technology, the fact that it is affordable, and you can create this yourself. And again, this wind turbine that I'm talking about, it is also open source. So I've released the files online for free. I'll just put that link for that, the open source, all the design files and all is all basically available there. So I've released all the files for free online. Anybody in the world can download those parts, 3D print them, assemble their first wind turbine, and get started with research in additive in renewable energy. So I wanted to create a story around renewable energy, story around 3D printing, and story around democratize manufacturing, and get a lot more people on board into taking power, taking the responsibility for their resources. And primarily I was targeting college students, right? I mean, all of them have a fourth year projects, and I wanted them to sort of use that entire semester of the time to possibly do something, apply themselves more when it comes down to things that we really need, like research in renewable energy. And this wind turbine that I created, everything from the wind turbine blades, the sweep angle, the efficiency over there, to the generator itself, right? The generator was also 3D printed. And again, I made a motor that winds copper wire around a 3D printed part, and again create an entire story around how 3D printing can be used to, all these high-end technologies, high-end things can be easily done. And after sharing these files online, people from all around the world started recreating the turbines. Somebody from Australia, somebody from Japan, again, just saw the files online, was inspired by a story, decided to make it for themselves, and not only make it for themselves, but make the project a little better. Every single time somebody would remake it, they would put in their own flair, their own understanding, their own sort of R&D, and make the project a little better, share it back with the community. So this entire thing around the wind turbine and Antarctica became an entire community of people from all around the world that are sharing information about renewable energy to make something better. And at the very basic, if somebody is interested, or any of your students are interested in asking you what kind of project should I work on, I mean, I've put the link. Do share it with your students if they're interested to sort of take it up and do it themselves.
Hello, sir. Good evening. I'm Vinod Kumar from
Evening, sir. I can
Mechanical
hear you.
Department of Canara Engineering College. So thank you so much for giving a wonderful presentation. It was some things actually we can't believe, but when you present it, we had to believe. That's what I can tell regarding that presentation. Now, talking about the 3D printer, sir, what I find usually the problem is when we have a 3D printer in our college. So when we print uh, something on the 3D printer, the main problem that we find is with respect to the strength.
Hmm.
Uh, Sometimes the finishing may not be good. Sometimes the strength will not be good. But if you try to slice it again here, it takes a lot of time. So for a particular application, how to decide this temperature, how to decide this slicing, is there any standard procedure for this? That's
Yes,
my question.
that's a good question, and again, it sort of highlights the problem that I talked about before. About there's so many materials available, so many different processes in 3D printing, and in the different processes, there's so many parameters in 3D printing, right? And because our goal is to make sure that the customer meets his application, we will use our understanding and try telling you about what material to use, what slicing settings to use, what process to use. Say, for example, even if FDM or FFF is not applicable for this process will tell you that this is not the right way to go. So we understand, these problems are there, but there's so many materials that are available, say from carbon fiber composites to high temperature metal replacement thermoplastics that can be printed on FDM machine. And again, even the other processes, your SLA, SLS, MJF, all of these other processes in 3D printing also exist. I think you start with your application, and I think we can get on a call after this as well to understand what you're trying to do. And I could suggest what are the right material, what are the right properties to slicing settings to use, because definitely again 3D printing is sort of not understood at that level where you could put in the slicing settings into an FEA software, and then it could tell you what are the strength characteristics of your part. We're just not there yet. But I do know that research is being done on that to make the process about slicing and all easier. So it's not just the material, it's not just the process, it's also the settings that you use for 3D printing. And I think when you have complete freedom, right, you have complete geometric freedom, I think it also comes with some caveats when it comes down to some confusion that comes along with it about, what do you really need to do to achieve your application. But I've seen 3D printed parts do interesting things. You saw it in that slide where I am bending up to 3 mm MS steel for your sheet metal forming. Again, it's just a matter of what are the material to use and what slicing setting to use, and again, combination of the both.
Okay, sir. Thank you.
Any questions? Any questions from the audience? I think we have no questions.
All right, then thank you so much for having me.
Thank you, sir. Okay, thank you.
And feel free to call for contacting with my details.
Okay, we will share it. We will share it definitely. We would like to ask you to share your PPT also, so that we can transfer it to our beloved participants. So
Sure.
I would like to ask Nagesh Kamat sir to give a vote of thanks.
Thank you, Naveen sir. It was a very good session. I thank on behalf of Department of Mechanical Engineering and Canara Engineering College as a whole. I thank Mr. Vijay Varada, CEO and co-founder of Fracktal Works. Sir, it's always a pleasure interacting with the industry, and this was no exception. I think all the doubts, if any, still are there, that will be now communicated to you, and I think you will be answering the doubts through the mail ID which you have given to us. And I feel such interactions between industry and academia or the institutions should happen in future also. So once again, I thank you very much, sir, for your valuable time, and thank you very much.
Thank you, sir.
Thank you, everyone. Okay, so we thank all the participants for today's session for participating. We'll be posting the feedback link in the chat box. So I request all the participants to fill the feedback for attendance and feedback based on this session. Thank you, Vijay sir. I would like to thank Vasudev sir also for communicating and being with us during this communication of arranging this session for the participants. Thank you.